Hello everyone, it's Mr. White, and I am hoping that everyone is healthy and that their families are healthy and that you're following the advice of our medical experts and practicing safe social distancing. Today is going to be the first day of our distance learning, and we're going to be working on the Pythagorean Theorem. Now this is chapter 2 in your textbook, and I have some sheets that have been posted in PDF format that you can download, and you can use them to copy out this lesson, or if you would prefer, you can take a piece of paper and copy out the questions, and you can work from there. All right, so let's take a look what we have here. We're going to be looking at the Pythagorean Theorem. Now, I believe most of you have seen this at different times in your school history. So we're going to talk about key concepts. First of all, we need to make sure that we're talking about right triangles. This will only work for a right triangle. And in a right triangle, we have a 90-degree angle. It's represented by that little box there. So that's 90 degrees between this side and this side. And when we have that, we have 1, 2, 3 sides for the triangle. And one of the sides we call the hypotenuse. Now the hypotenuse is the longest side in the triangle, and it's also the side that's going to be directly opposite the 90-degree angle. So it's going to be right across from the 90 degrees. This side here is called the hypotenuse. Hypotenuse. Now, this side and this side are called the legs of the triangle. This will be a leg and this will be a leg, and we just refer to them as side 1 or side 2, or just side and the hypotenuse. Now, Pythagorean came up with a formula for the right angle triangles, and that was that the square of the hypotenuse is equal to the sum of the square of the legs. And this is the way we look at it these days. We talk about a formula being a squared plus b squared equals c squared. The problem with that is that c must always be the hypotenuse, okay? So if you set up a triangle that looks like this, and if I was to talk about it in terms of a, b, and c, then you can definitely see that c is opposite the 90 degrees. Therefore, it's also the longest side. This is definitely the hypotenuse. Therefore, the formula can be a squared plus b squared equals c squared. However, if I was to take that same triangle, but this time label it a, b, c, this formula, a squared plus b squared equals c squared, would not work for this triangle. This triangle, it would have to be a squared plus c squared equals b squared, because b is the hypotenuse side. So even though you've probably learned the formula as a squared plus b squared equals c squared, a better formula is to say side squared plus side squared equals hypotenuse squared. Something else I'd like you to know about the Pythagorean theorem is that it really wasn't discovered and talked about in terms of lengths when they first came about it. If I look at this as side A and this is side B and this is side C, the way Pythagorean really looked at this was he made a square on the one leg, and this area would be B, this length is B, this length is B, so this area was B squared. This area here so that was A, and this was A, so the area here was A squared. And what Pythagoras came up with was that those two areas, if you added those two areas, would equal the area drawn off of the hypotenuse side. And I'm going to link a little video to that that'll explain that a little bit clearer. So you can look at that when this is done. So what do we have so far? we have a formula, which is the side squared plus side squared equals hypotenuse squared. We have a right angle triangle. We know that the hypotenuse is the longest side and it's opposite the 90 degrees. And now we're going to see how we can use this. You can use the Pythagorean theorem to find the length of one side of any right triangle given the lengths of the other two sides. So, we're going to do some examples here. Finding the length of a side. Here's a side that's missing. We know that this one's going to be 10 centimeters. We know that this one's going to be 8 centimeters. So, using our formula, we know that it's going to be side squared, which is, I can choose 8 to be my first side, plus the other side, which will be 10, and that's going to equal x squared. So this is going to be 64 plus 100 equals x squared. Using a calculator, I'm going to come up with 164 equals x squared. Now, what I need to do is take the square root of both sides. So we're going to take the square root of this side. We're going to take the square root of this side. By taking the square root of this side, this just becomes x. Using our calculator, 164 is going to be 12.8. We look back at the question. It says round your answer to one decimal place. So I've got the decimal. I've got 0.8. I look over here. This is 0. If it was 5 or greater, I would round up, but it's not. So it's going to be approximately, because it's not equal, because I'm leaving a little bit off. I left this amount off. So it's going to be 12.8. And that is rounded to one decimal. Now something I should point out is that when you take the square root, there's actually a plus or a minus answer that'll work. Let's talk about that for a minute. Let's say I had x squared equals 9. And I'm looking for the answers that would equal 9. Well, there's two answers. One of them is plus 3 squared will give you positive 3 times positive 3, which is positive 9. But we could also have negative 3 squared, which is negative 3 times negative 3. A negative times a negative is a positive. 3 times 3 is 9. So there's actually two answers to this question. So x squared equals 9. When we take the square root of both sides, there's actually going to be two answers, plus and minus 3. Now in this particular case, we're talking about lengths. So a negative 12.8 wouldn't make a lot of sense here. But it's important for you to know that, yes, there are two answers mathematically, plus or minus, but since it's a length, the negative doesn't make sense, so it's simply going to be x equals approximately 12.8. And we look at units, centimeters in this case. All right, the second example. So, I've got a side, 24 millimeters. I've got a side, 20 millimeters. I've got a side that's an unknown x. This is my 90-degree angle. That means that this must be my hypotenuse, which means that the formula is going to be side squared, which is x squared, plus 20 squared, the other side, the other leg if you will, equals the hypotenuse squared, which is going to be 24 squared. So this one's set up just a little bit differently. I'm going to try focusing here a little bit, see if this comes in a bit better. Okay, so I've got x squared I've got x squared plus 20 squared, which is 400, equals 24 squared, which is 576. I need to get x squared by itself, so I'm going to move the 400 over. Now be careful with that moving over idea. Remember, I'm taking 400 away from this side, so I take 400 away from this side. That's going to leave me with x squared equals 176. So then we're going to take the square root of both sides. Notice this time I didn't write the square root and the x squared, because I know that they're going to cancel each other out anyway, so I just went straight to x. 176 square rooted is 13.2. It says to round to one decimal place, so I look after the 2 and it's a 6. That's greater than 5, so it's going to be approximately 13.3 millimeters. Now, I didn't put the plus or minus in this one. I did that argument over here. You're not going to have to do the argument every time, but there is going to come a time when we do our math and both answers are going to matter, the positive one and the negative one. It doesn't in this case because we're dealing with length, so I'm good enough to go straight for the positive one. All right, let's take a look what else we have. I have another example here. So we have a side, and we have a side. It is a right triangle, so I can use the Pythagorean Theorem. Let's take a look at this. This is my 90 degree, so this is going to be my hypotenuse. This will just be a leg. This will just be another leg. So it's going to be one of the legs squared plus the other leg squared equals the hypotenuse squared. I don't even write out the formula, guys. I don't get hung up on what's A, B, and C. I know that it's side squared plus side squared equals the hypotenuse squared. So what I'm going to do is 22 squared is 484 plus x squared equals, and I think that's going to be 900, but let's check. Yeah, 900. So now it's going to be x squared equals 900 minus 484. I don't trust myself to do that because I want to make sure I get it right. So it's 416. So I'm going to take the square root of both sides. I want to be very mathematical this time, so I'm putting the plus and minus. So that's going to give me an answer of plus or minus 20.39, so 20.4. But the negative doesn't make sense in this case because we're talking about a length. So you're going to omit. That's the official word that you use in math. Omit, it means forget about or let's not use the negative. Omit the negative because it's a length, and we'll get a final answer of 20.4 feet. All right, example 2. A ladder is placed on a wall which is 10 feet tall, 10 feet high. The foot of the ladder is placed 7 feet from the base of the wall. So here's my wall. This is the ground. So this is going to be 7 feet. How long is the ladder? We know that the wall, it said the wall is 10 feet high. So this is 10 feet. And the question is, how long is the ladder? So sometimes you're going to have to make a diagram. Sometimes you're going to have to put the numbers where they go. So let's look at this. It is a right triangle, so we can use Pythagorean Theorem. So this is the 90 degrees, which means that my unknown ladder is acting as the hypotenuse. It's the longest side here. This is going to be one of the legs. This is the other legs. So it's going to be 7 squared plus 10 squared equals hypotenuse squared. Now I can write it that way, or if I wanted to, I could have started with the ladder and said that the hypotenuse squared is going to be 7 squared plus 10 squared. Take a look at both of those and make sure that that makes sense to you, that they mean the same thing. So x squared equals 49 plus 100. X squared equals 149. We're going to take the square root of both sides, and we're going to come up with 12.2. Now it said to the nearest whole number this time. So the nearest whole number will be 12. So x equals approximately, that's what that symbol stands for, 12, and I think it's feet. There you go. All right, we have one last example to finish off, and then you're going to have some work to do. So a new sports complex has to build a wheelchair ramp outside the front doors. The current stairs go through a vertical rise of 1.5 meters. A vertical means this way, okay? So it's a vertical rise. So here's your 1.5 meters. That's my vertical rise. if the ramp is to be 15 meters long, how far from the sports complex will the ramp start? So the ramp is to be 15 meters long. So this is the ramp, okay? This is the distance from the stairs to the end of the ramp. So if this is the ramp, then that's going to be 15 meters along that side. They want to know how far from the sports complex will the ramp start. So they really want to know that distance there. This is going to be a right angle. So it's a right triangle. We can use Pythagorean Theorem. That's going to be my hypotenuse. So that means that I can say that 15 squared equals the other two sides squared. Or if I wanted to, I could write that like x squared plus 1.5 squared equals 15 squared. So using my calculator, I'm going to get x squared plus 2.25 equals 225. X squared equals 225 minus 225. That's going to give us x squared equals 222.75. Square root both sides. And we have an answer of approximately 14.9. Now it says to one decimal place. So 14.9 meters. Okay, ladies and gentlemen, that's our first lesson. That'll be enough for today. I'll give you some homework to work on. You need to be checking the LMS daily. You need to be checking your school email and the shell to make sure that you're keeping up. I'll see you in a day or two, and I'll give you some more work to continue from there. Now remember, you need to work on this material because you will be tested on it, and I will be gathering grades for you. We'll be doing that distance learning, and we'll be taking a look at different ways that we can do that, but you definitely need to be practicing this, going over it, and make sure that you have the skills to be able to do the questions on your own. All right, we'll see you all very shortly.